Assalamu alaikum, dear students, and welcome you all for today's science class. Let's start with the talk of the day. And today's talk of the day is Allah likes those who are thankful. As you know, students, that Allah likes those who are thankful because Allah says in Quran that be thankful to me means say Alhamdulillah, then I will give you more. And it is the best dua also. So if we want more blessings from Allah, then we should be thankful for His countless blessings in the form of health, wealth, abilities or talents we have, and of course, this life as a Muslim, right? Okay, students, as you know, in previous lessons, we had discussed about discovery of metals, their properties, and how do they react. Do you remember what are metals? Yes, metals are typically hard, solid, shiny material which are good conductors of heat and electricity. And the story of metals is very old. People have been using metals since long. The metals we use today to make buildings, computers, cars, trucks, and many other products come from the earth, right? So the topic for today's discussion is extraction of metals from their ores. Clear? Students, remember that in nature, metals are found in the rocks in the form of compounds. Basically, metals are mixed with rocks. So these naturally occurring compounds of metals through which we can extract pure metal are called ores. Clear? I had told you that metals, they are found in the rocks, right? In the form of compounds. And these metals, they basically mix with rocks, mud, sand, and soil. So these naturally occurring compounds of metals through which we can extract metal, we can extract pure metal. These compounds, they are called ores. What is an ore? Ore is a natural rock which contains naturally occurring metal compound through which we can extract pure metal. Clear? Extract metal means obtaining metal from metal compound found in the rocks. Clear? So, in other words, we can say that ore is basically a natural rock which contains naturally occurring metal compound. And that naturally occurring metal compound is separated from the rocks firstly. Here, in first step, we separate metal compound from the rock. And then from that metal compound, we extract or remove pure metal by using different methods, which we will discuss in our lesson. Students, do you remember the reactivity series? How can you define reactivity series? In reactivity series, as you know, metals are ranked according to the way they react. So, based on reactivity series, we know that Mostly metals, they do not exist in pure state. Most of the metals, they do not exist in pure state because they are very reactive. That's why they combine with other elements like oxygen, sulfur, or carbon and form ores. When metals combine with elements like sulfur, oxygen, and carbon, they form ores or they are called ores. It means metals are found in compound in our earth, right? Let's see chemical nature of the ores. Metal ores are found in the form of rocks, and these metal ores found in the rocks, they are present in the form of metal oxides, metal sulfides, or metal carbonates, right? Metal ores are found in the rocks in the form of metal oxides, metal sulfides, or metal carbonates. And these ores, as I have told you, present in the rocks in our earth. Now the question is how these ores are formed. Let's see. Metal oxides. Metal oxide ores, as the name indicates, are formed by metal with oxygen. Clear? Metal oxide ores are formed when a metal combines with oxygen element. Metal sulfide ores are formed by combining metal with sulfur. Metal carbonate ores are formed by combining metal with carbon and oxygen. This is how these metal ores are formed in our earth by combining metals with oxygen or sulfur or carbon. Now the question is how metal ores are formed. Let's see examples of different types of ores. And one of the most common ores found in earth crust is bauxite. Most common ore found in our earth crust, that is called bauxite. This is the picture where I'm flashing light. This is the picture of bauxite. What is bauxite and how it is formed? Bauxite is an aluminium ore. The main component, the main element is aluminium. So bauxite is basically an aluminium ore. It contains compound that is aluminium oxide. When aluminium is mixed or reacts with oxygen, it forms aluminium oxide compound, and that compound is called aluminium ore, and a name is given to aluminium ore, that is bauxite. Next example is hematite. Hematite is an iron ore. It contains compound that is iron oxide. Next is copper pyrite. Copper pyrite is an ore of copper, or you may say that copper pyrite is copper ore. It contains compound that is called copper sulfide. Clear? Biscophyte. Another example of ore is biscophyte. Biscophyte is an ore of magnesium, and it contains a compound that is called magnesium chloride. Clear? And from these ores, basically, we can extract metals. In other words, we can say that ores are mined to get metals from them. Mining means extracting metals, removing metals from an ore. Clear? Students, the process of mining from discovery of an ore body through extraction of metals consists of several steps. Clear? And the decision whether or not to mine an ore depends on number of things, number of factors, such as how much ore is there in that rock. Clear? Second point, which the mining company considers, that how much it will cost to mine. Next point which they consider, how much it will cost to extract the metal from the ore and purify it. Will it be economical or not? Next point which they consider is that if there is a market for the metal. Next point, if a profit can be made or not. And the last point which the mining companies they usually consider is what it would be the effect of that extraction of metal on the environment. Will it cause pollution or will it cause contamination of soil or groundwater or surface water by the chemicals emitted from the mining process? So after seeing all these points, mining company makes this decision, right? So mining company firstly does this mine planning, and then after seeing all these points, the mining company makes the decision whether we have to mine ore or not. Because students, mining an ore is not an easy task. It is a very, very expensive process. Not only a large number of laborers, manpower are required, but huge, heavy machinery is also required. Heavy machinery like bulldozers, drills, excavators, they are needed to mine an ore. That's why, after getting all the information, the decision for mining is done, right? Okay, let's move towards the next slide. The process of getting metals from ores is called extraction of metals, right? When we extract metals from the ores, this process is called extraction of metals. And the extraction of metal, this process is done in two steps. Mainly two steps are involved in extraction of metals. In first step, the metal compound is separated from the rock, another waste material. In second step, the metal has to be extracted from the metal compound. Clear? Now, if we see the extraction of unreactive metals, then you will notice and you will observe that unreactive metals, as you know, they are present at the bottom of reactivity series. As they are unreactive, so they are found as free metals, means they occur in pure form only. They are not combined with any other element. They are not found in rocks in the form of compounds or ores. For example, gold. Clear? Okay, let's talk about the metals of extraction of metals of less reactive metals. Clear? Extraction of less reactive metals. Students, as you know, the metals which are present low in reactivity series, the metals which are present low in reactivity series, they are easier to extract. Why? Why they are easier to extract? Because they form less stable compounds. They are less reactive, so they form less stable compounds. So these metals can be separated from their compounds or ores easily. And the process we use for extracting metals from their compounds is smelting. So we can say that the lower the position of metal in the reactivity series, the easier it is to extract from their ores. And the process we usually use for extraction of less reactive metal is smelting. Okay, let's take an example of extraction of iron, which is less reactive metal. Extraction of iron by smelting process. Clear? As you know, students, oxygen is abundant in atmosphere, and mostly metals, they are reactive, right? Except gold, silver, or platinum. So metals, when they react with oxygen present in the atmosphere, they form metal oxides. Let's take an example of iron. When iron reacts with oxygen, it forms iron oxide, which is an iron ore, and it is commonly known as rust. Now, we need to know how to remove this oxygen to get pure metal iron from iron oxide. And the cheapest and easiest way is to perform smelting process, which is done in blast furnace. This is blast furnace where I'm flashing light. What is blast furnace? Blast furnace is a huge structure or reactor which is used for smelting process. Clear? Now let's see steps of smelting process. Step 1. In step 1, in a blast furnace, ores of iron oxide, or it is also called hematite, along with coke, coke means carbon, and limestone, calcium carbonate. This mixture is put from its top. In first step, iron ore, hematite, along with coke and limestone. This mixture is added or put at the top of the blast furnace. In second step, hot air is blown from the bottom of the blast furnace to provide oxygen. Clear? In step 3, coke is burnt in hot air and forms carbon monoxide. Burning of coke supplies most of heat required in this process. In step number 4, carbon monoxide, which is produced, and heat moves to the upper part of the blast furnace, and it takes oxygen from iron oxide and forms carbon dioxide. After that, it leaves behind the iron metal because the oxygen is lost or removed from the hematite ore, from iron oxide ore. Clear? Okay, let's see the next step. We have added limestone also in step number 1, right? Now the purpose of adding limestone is to remove impurities from iron. The iron which is left behind in this step, in 5th step. So why we had added limestone? Because this limestone, it helps to remove the impurities from that iron if it is attached with the iron metal. So during smelting process, limestone is decomposed or breaks down and produces lime, that is calcium oxide. Clear? Then lime reacts with impurities like sand. Clear? Present in the iron or attached with the iron. And in this way, impurities are removed from the iron. And what is left behind? Pure iron metal is left behind, which is collected from the bottom of the furnace, right? Pure iron metal collects at the bottom of the blast furnace. As you know, carbon dioxide is also produced in this process. So the carbon dioxide produced in this process as waste gas, which escapes at the top of the blast furnace opening from this side. This is how we extract pure iron through smelting process. Clear? And the impurities or waste material which is removed from this part of blast furnace is called slag. Or in other words, you can say that the impurities are removed from blast furnace in the form of slag. Slag is basically a stony waste or waste material which can be used in cement production or road work, right? This is how you can represent the process of smelting in the form of chemical reactions, right? In zone of combustion, you have learned that carbon or coke, it is burnt in hot air, right? And when carbon or coke is burnt in hot air, it has produced carbon monoxide. And by the reaction, this reaction, the temperature of the blast furnace will increase, right? Through this reaction, a lot of heat energy will be produced, which increases the temperature. Then, in zone of reduction, carbon monoxide, which is produced in first step, it reacts with iron oxide ore and takes oxygen from iron oxide and forms carbon dioxide. And what is left behind? Iron. Then, in zone of slag formation, limestone which we have added from the top of blast furnace along with iron ore is decomposed into calcium oxide, that is called lime, and carbon dioxide, right? Carbon dioxide which is produced in this process, it is removed from an opening of blast furnace into the surrounding. Calcium oxide or lime, which is produced by the decomposition of limestone, it reacts or combines with impurities which are attached with the iron, like sand. These impurities are like sand. When calcium oxide reacts with sand, it forms slag. Slag formation will be done. And I have told you that what is a slag? Slag is a stony waste which is removed from the bottom of the blast furnace. Now, the iron which is left behind, that is pure iron. It is in molten form. And this iron, we can remove this iron from the blast furnace now. Right? But students, we can't do this smelting process with all the metals. Clear? Only we can do this smelting process for those metals which are less reactive. Most reactive metals form stable compounds, right? If the metals they are highly reactive, you will observe that they will form stable compounds. And to break these stable compounds, lot of energy is required. So, to extract reactive metals, highly reactive metals, we use another process that is called electrolysis process, which is very expensive process also. Clear? So, the higher the position of metal in reactivity series, we can say that the harder it is to extract the metal from its ore. So the process of electrolysis is used to extract them from their ores. Clear? If we want to extract less reactive metal, we will use smelting process. If we want to extract highly reactive metals, then we will use electrolysis process. Now let's see what is electrolysis. In electrolysis, lysis is a Latin word. Electro means by using electricity, and lysis is a Latin word which means splitting or breakdown. So electrolysis is a process of splitting or breakdown of ionic compounds into their pure elements by passing an electric current through a solution or a liquid, right? In electrolysis, an ionic compound is breakdown or it is broken down into pure elements by passing an electricity. That's why this process is called electrolysis process. Clear? Okay, students, now we will see that how aluminium is extracted from its ore. As you know, aluminium is the most abundant metal in the earth crust, but one of the most expensive one also. It is that metal which is expensive to extract. Why? Because it is highly reactive and it forms highly stable compound. That's why a lot of electricity is used to extract it. And aluminium ore is called bauxite. Clear? Let's see steps of extraction of aluminium by electrolysis. Right? In first step of extraction of aluminium by electrolysis, impurities are removed from bauxite, from aluminium ore, leaving behind pure aluminium oxide, which is called alumina. Pure aluminium oxide, after removing the impurities, is called alumina. Clear? In second step, aluminium oxide is dissolved in molten cryolite to lower its melting point. Students, in electrolysis, keep remember this point that in electrolysis, ions they need to pass through electrolyte, right? Electrolyte or solution. So for this purpose, aluminium oxide must be made molten because ions they cannot pass through solid substance. Ions can easily pass through molten material. But if you observe aluminium oxide, it has a very high melting point, like 2000 degrees centigrade. So instead of trying to melt it, aluminium oxide is dissolved in molten cryolite, right? What is cryolite? Cryolite is aluminium compound with a much lower melting point. And when aluminium oxide is dissolved in molten cryolite, it reduces or lowers the melting point of aluminium oxide. And using this process reduces some of the costs in extracting metal also. Clear? Then in third step, aluminium oxide, which is now we have dissolved it in molten cryolite. It is put in electrolysis equipment, which you see over here in this slide. This is electrolysis equipment. This electrolysis equipment contains two electrodes made of graphite. Graphite means carbon. Two electrodes, which are made up of graphite, are placed in this equipment. Clear? One electrode is positive electrode. One electrode is positive electrode and the second electrode is negative electrode. Clear? Positive electrode is called anode and negative electrode is called cathode. If you see in this picture, this tank lined with carbon, cathode. Here, this tank lined with carbon, cathode. Cathode is negative electrode, right? And these are, where I am flashing light, these are anode. Anode are positive electrode. Cathode are negative electrode. Anodes are positive electrode. Clear? So let's move on to the next step. These electrodes are connected with wire and some source of power like battery so that ions can flow in a complete circuit. Clear? When an electric current is passed through it, then what will happen? Oxygen ions from the aluminium oxide, they move towards positive anode, right? Oxygen ions, they move towards the positive anode, and aluminium ions, they move towards the negative cathode. Clear? Now let's see what happens at the cathode, right? As I have told you, aluminium ions, after passing the electricity through this molten aluminium oxide, which is dissolved in cryolite, aluminium ions from the aluminium oxide, they will be attracted towards the cathode. Clear? And forms pure aluminium atoms, which sink to the bottom of the tank here, right? And it is basically pure liquid metal which is produced at this step, which is collected as pure aluminium metal. Aluminium sinks because it is more dense. Clear? So in this way, we get pure aluminium through electrolysis. Now let's see what happens at the anode. Oxygen produced at the anode, oxygen from the aluminium oxide in molten cryolite will be attracted towards the anode, right? And this oxygen which is produced at the anode, it reacts with carbon of graphite, right? It reacts with carbon of graphite and forms carbon dioxide, which bubbles off from this equipment into the surrounding. Clear? So in this way, we have got pure aluminium metal by the process of electrolysis. Clear? So what we have studied so far, that ores are present in our earth crust and metals of high reactivity are extracted from their ores by the process of electrolysis. Clear? And we have also discussed that metals of low reactivity are extracted from their ores by the process of smelting. Okay, students, this is all for today. Now, if you have any query regarding today's lesson, you can ask. Homework time. And what is your today's homework? You have to do question answers of test yourself of page 37 and 39 on your science copies. Homework is also uploaded in Google Classroom, right? This is all for today's lesson. Thank you all and goodbye from my side.